See, the name of the chapter is solutions as such, but ideally name should be colligative properties. Why colligative properties? What are colligative properties? The number of molecules or the number of moles of solute, not mass. Indirectly तुम कह सकते हो mass भी, but those properties which are dependent on number of molecules or moles of solute. See, it's a very, the whole chapter, in the whole chapter we are only going to study those things which will be directly proportional or those properties which will be directly proportional to the number of moles or the number of molecules of solute. That is the same thing. Or not even solute, even if you can say that something is dependent only on the number of moles. All those properties which are depending on the number of molecules are known as colligative properties. So, see, the overview of the chapter is, this chapter is based on 4 formulas. Elevation in boiling point. First is relative lowering of vapor pressure. Second is osmotic pressure. Third is molar elevation in boiling point. And fourth is molar depression. See, these are the 4 properties which are based only on the number of molecules of solute. So all these are colligative properties. That's why we will study all these one by one. So these are the, frankly speaking, this chapter is based only on 4 formulae and plus Raoult's law plus Henry's law. So like 6 formulas and the chapter is over. But the point is, understanding these concepts takes time. So we'll try to finish these 4 in today's lecture, and next lecture will cover Raoult's law and Henry's law. So by next lecture, by the end of next lecture, solutions will be done. Clear? Just note it down. This is just an overview of what we are going to do. Few definitions which you must know. I mean, just a quick revision. What is molarity? This is known as molarity. This is moles of solute. Molarity. Suppose I have a liquid A liquid. See, what is the difference between evaporation and boiling?
As a surface phenomena, boiling is a bulk phenomena.
Evaporation is a surface phenomena, boiling is a bulk phenomena. Boiling happens at a given temperature, evaporation happens at any temperature, right? At most of the temperature it's going to happen. So, suppose I take a liquid A. So after some time, if I take this beaker, I will have some A particles in the form of gases. Why? Because again the same thing, evaporation. So it is a surface phenomena, so there will be some particles which will be in the form of gas. Clear? Now, as the time goes on, what happens? After some time, there will be an equilibrium between A liquid and A gas. Clear? Once this equilibrium is achieved, the pressure exerted by A gas on the surface of A liquid is known as vapor pressure. Once an equilibrium like this is achieved, I can say the pressure exerted by A gas on the surface of A liquid is known as vapor pressure. And this is once the equilibrium is reached. See, vapor pressure is very important for this chapter because the first colligative property is relative lowering of vapor pressure. One thing which you should know is it is dependent on the number of molecules present at the surface because it is a surface phenomena. So, if the number of molecules decreases, then the vapor pressure is also going to decrease. Number of molecules present at the surface. And there are few things on which vapor pressure is dependent. One of them is temperature. So if the temperature increases, vapor pressure increases. It depends on the type of solvent also. you take, if boiling point of solvent is high, then you can say the vapor pressure will be low. And another thing, if you add a non-volatile solute, or if you add something which is going to curb the number of molecules present on the surface of this liquid, then what will happen? The vapor pressure will decrease. So that is the first law. On addition of a non-volatile solute, what happens? You can see that suppose if this is the pure liquid, the vapor pressure is say P naught. Now if I add something and it is non-volatile, what does non-volatile imply? It is not evaporating. Okay. So if I add a non-volatile solute to this, what will happen? Suppose this is a liquid. This is a liquid surface, right? As of now, it is pure liquid. Say this is a non-volatile solute. On addition of this, some of the particles which are present on the surface will decrease. And since it is a surface phenomena, I can say the vapor pressure will now decrease. Are we clear? Yes. This we will study now, but this is just a general definition of how do we start with vapor pressure. Are we clear? Just note it down. What is Raoult's law?
That the vapor pressure exerted by a volatile, what do you call it? Solute.
By a non-volatile solute equal to
Directly proportional to the mole fraction
of the solute
in the solution.
in the solvent.
Yes.
Yeah, in the solution. See, what you are saying is right. Suppose I have a solvent A. This is a solvent. Say it is water. And suppose I add a solute B. B is the solute. Say the solute is NaCl. And say A is water. Initially you had only pure water. Right? See, the concept is, if you take a pure solute, say water, then you have a vapor pressure, say P naught. Now suppose I am using a non-volatile solute, say NaCl, and I am adding it in a solvent. Because now it is a mixture of solute and solvent. So now it is a new solution. Suppose I want to find out the vapor pressure of this whole new solution. So if I want to find out P solution, what I can say? It is proportional to vapor pressure of solution. That is proportional to
The mole fraction of this.
the mole fraction of solute or solvent? X solvent or solute? So if I take the mole fraction of the solvent, suppose I have Na moles of this and I have Nb moles of this. Total moles are Na plus Nb. So after this whole mixture, I can say the partial pressure or the pressure due to this whole solution is proportional to nothing but the mole fraction of the solute, which will be Nb upon Na plus Nb. Do not get confused by the first colligative property in this, because in that case it is X solute. Here it is X solvent. Are we clear? Next class we will do it again. More important thing is what we are going to do now, which is the first colligative property, which is relative lowering of vapor pressure. Suppose I have a solvent and I add a non-volatile solute. Initially, if only solvent was present, the pressure was P naught, and P naught is due to pure solvent. On addition of a non-volatile solute, to this same solvent, the new found pressure is P, which is P solution. So P naught will be greater than P or less than P?
P naught will be greater than
Why P naught will be greater than P? The same example is given. I think it is clear, right?
Yes, sir.
Okay. So I can say P naught is greater than P, or I can say P naught minus P is lowering of vapor pressure. Initially it was P naught, now it is P. So how